Yes, class, this is the video for section 2.3. We're going to do this in two parts. Okay, so this is the first part of the video, and this section talks about properties of functions. Okay, the following are the learning objectives. There are 6 of them. So for this video, we'll cover the first 4, and then the second video will cover the last 2. Okay, so at the end of this, you should be able to identify odd and even functions from a graph, and using algebra to find whether a function is odd or even. And then use a graph to determine whether a function is increasing, decreasing, or constant. And then we find the average rate of change for a function. We also, under that, we also consider the slope and then the equation of a secant line. All right. So first, let's define what is an even function is. That if you are given a function of f of x, okay, and then if you substitute negative x, and then you get the same function as the original, then we say that this function is what? Is even. Okay, so it has the same, if you substitute negative x, it's going to have the same domain and the same range as what the function. Now, for an odd function, on the other hand, if we substitute what? Negative x for x in the function f of x, and then we get the function which is what? Negative times the original. Okay, that's negative times what? The original. Okay, function which is f of x. Then this function is what? Is odd. Okay, so that's the definition. Now, in terms of the graph, in terms of symmetry, what can we say? All right, even functions are symmetric with respect to what? Y-axis. And then odd functions are symmetric with respect to what? The origin. Okay, so on the other hand, if you have a graph that is symmetric about the x-axis, sorry, the y-axis, then we say that that function is even. If it is symmetric about the origin, then we say that function is what? Is odd. Okay, so here are some examples. So first, we are given a graph. We want to know or want to determine whether the graph is odd, even, or neither. Okay, so if I look at this function here, this graph, actually it is not symmetric with respect to the y-axis, neither the what? The origin, but it is technically, it is what? Symmetric with respect to what? The x-axis. Okay, but the x-axis has nothing to do with determining whether a function is odd or even. So in this case, we say that the function is neither odd or even. Okay, odd or even. Okay, the function is neither odd, even, nor odd because the graph is neither symmetric with respect to the y-axis nor symmetric with respect to what? The origin. Okay, next, look at the graph B. Okay, look at this graph B here. Now, if I took out the constants, I draw the distance lines, okay, it's the same. So we see that this graph is what? Symmetric, okay? It's symmetric with respect to, when I write WRT, I mean with respect to, okay? With respect to what? Y-axis. So we say that the function, in this case, y equal to whatever f of s, is what? Is what? Even. Okay. The function y equal to f of x, in this case for the part C, is what? Symmetric. Okay. Symmetric with respect to what? The origin. So we always say that symmetric about the origin. So this is also, this is odd. So this is even, this is what? This is odd. Part B is even, and then C is what? Is odd function. Okay. Based on what? The graphs. Right. Now, here we want to determine whether a function is odd or even algebraically. algebraically. That is, given an equation, we want to determine whether it is what? Odd or even. Okay. Now, don't forget, this is what we're going to check. If we substitute negative x for the function, and then we get what the same as the original, we say that this is what? Even. That's by the definition. Or if we do the same thing and we get negative of times the original, f of x, then the function is what? Is odd. Okay, so we're going to pick each one and then determine that algebraically. Okay, part A, well, what we do is that we're going to find negative for f of negative x. So wherever we see x, we substitute negative x. So we have got 2 times minus x all squared plus what? Plus 3. Okay, now this is the same as if you square negative x, you get positive x, which is what? X squared plus what? 3. Now look at this expression here. It's the same as that. So it's the same. So we say that this is what? F of x. So what we have done is that f of negative x is equal to f of x. Therefore, we say that f is what? Is even. Okay. Now let's go to part B. Okay. We do the same thing. We're going to check that this is equal to g of x, or we're going to check whether it is what? It is equal to negative what? G of x. Okay, that is g of negative x is equal to that. If we don't get any of these, then we say that it's neither odd or even. Okay, so let's just go. G of negative x, the expression is x cubed, so that's minus x, put that in parentheses, x cubed plus what? Plus 3. Well, let's give it what? Negative, because the exponent is what? Odd. It's going to be negative x cubed plus what? 3. Okay. But is it the same as negative g of x? Let's check that. What is negative of g of x? Okay. You have negative of g of x, which is what? X cubed plus 3. X cubed plus 3. Okay. This gives me negative x cubed minus 3. Now, you should see this first term is the same, but plus 3 is not the same as negative 3. Therefore, we will say that this function g of x, okay, g of x is what? Neither, is what? Neither even nor what? Odd. Okay, it's neither even nor what? Nor odd. Okay, let's go to the next one. We have h of x is equal to x cubed plus what? 4x. Then we're going to substitute what? Negative x into that. So we're going to check that negative h of negative x is either equal to the same h of x, or it is equal to a negative of what? H of x. Okay, so let's check that. Now let's find h of negative x. This gives me negative x cubed plus 4 times negative x. Now the first term will give me negative x cubed and then minus 4x. All right, 4 times negative x is negative 4x. Well, if we look at this and we factor negative 1 out, we're going to have minus 1 in parentheses, x cubed plus what? 4x. Now, notice that this is the same as what? H of x. There's original here. What's in the parentheses the same as that. So what we have there is what? Negative of that. So we have determined that minus of h of negative x is equal to negative of what? H of x. Therefore, we say that h is what? Is odd. Okay, let's go to part what? Part D. Okay, then we also do capital F of what? Negative x. We get 1 plus absolute value of what? Negative x. Okay, what's the absolute value of negative x? Is the same as what? Absolute value of what? Absolute value of x. Okay, all right, so we have this what? This is the same. We got what? F of what? X, negative x, sorry, is equal to capital F of what? X. So we say that this capital F is what? Is even. Now, if it is even, we say that in terms of symmetry, we say that F is what? Symmetric. Is symmetric with respect to what? The y-axis, because it is even. H is what? Symmetric with respect to what? It's the odd, so it's respect to what? The origin. Okay. If you go back to part A, because we got it to be even, we say that this is what? Symmetric. Okay, with respect to what? The y-axis, because it is what? It is even. Okay, so that brings us to that expression. Now we talked about determine whether a graph is symmetric with respect to y-axis or x-axis, or determine whether it is what? Odd, even, or neither, and then determine the similar thing using what? Algebra to find whether a function is what? Odd or even. Okay, now when we say a function is increasing, okay, we want to define, these are definitions. The increasing is what? Decreasing, or is constant. Now, when you say it is increasing, we are looking at what? X values. Okay, so a function increases that if I plug in x is equal to 1 into the function, I get 1, and then if I plug in x is equal to 2, and I see that the y values are increasing, that means the function is what? The function is increasing. But here, to write the intervals, okay, these are what? We're going to be intervals. And then that uses what? X values. So we'll be looking at what? X values, the interval X values, okay, for which what? The Y values is what? Increasing. Y value is what? Decreasing, or Y value is what? The Y values are increasing or decreasing or are constant. Okay, so this definition basically says that a function f is increasing on an interval if for any choice of x1, x2 in the interval, if you plug them into that, you will see that the second f of x2 is greater than f of x1. Or you can say that we are looking at the x values, okay, x values for which y values are increasing. Or sometimes I would just say that they're going uphill, in parentheses, can put uphill. It's going uphill, okay? Similarly, they are looking at the intervals, which are the x values, okay, for which, okay, the y values are decreasing, okay? The y values are decreasing. Or we are looking at what? They are going what? Downhill. They're going downhill. And then they say they are constant. They are still the y-x values for which they are all equal. For any value of x we plug in, is a horizontal line. Or we can say that the graph is what? Or can say that the graph is flat. Okay, the graph is flat. So here you say graph is going downhill. Okay, or you can say the graph is going what? Uphill. So if it's going uphill, it's increasing, downhill is decreasing, and then flat, it is what? It is constant. So let's look at this example. I mean, in the picture form or on a graph. All right. So as you see this function, as we are moving from left to right. Okay. Always we are going what? Left to what? To right. Okay, now the y values are going up. If you see from here, the y value is negative and it's going become positive on this graph. So you see that we are going uphill. Okay, we're going out uphill. So we're going to be what? All the x values, that will be the interval within where the function is behaving like that. or the graph is behaving like that. Now for the decreasing, similarly, you see that the y values are what is from going this way, is from positive and it's becoming negative, or it's getting smaller and smaller over the what, the interval what, the interval I. So in this case, we say that y is what, y is decreasing, or you can say that it's going what, downhill. Okay, it's going downhill. Now here, the graph is what, it is flat. Okay, it is flat, sorry. It is flat. And these are the, within these x values of interval, that's what we have. Okay. Now in writing this, it could be, you can use what, parentheses or brackets. All right. I'm going to use parentheses because that's what I feel that should be the right way. However, for your homework, my MATLAB, I mean, I takes whichever you write it. Either is what is interval notation, but if you include them, the endpoints, or if you don't include them, okay, they will all be the same. All right, so here's an example. For this, we want to determine where, okay, we want to find where the function is what, increasing, decreasing, or constant from the graph. Okay, so first, let's talk about increasing. Okay, so where it is what, it is going uphill. Okay, it's going uphill here, this part, and it's going uphill from here to that. Okay, now what are the x values? So here will be the x values within this, that's interval. You could see that was what, it's from -2, okay, to x is equal to what, 0. And then comma is also from, what is it? This is 3. So this point x is 3. 3 to what? What's the x value there? That will be what? 3 to 4. 3 to 4. So on these intervals, okay, on these intervals, the function f is what, is going uphill. Okay, now like I said, you can write this as what? Now the reason why the point exactly at 0 and the endpoint is -2, okay, you can include it in the increasing and decreasing, right? But for me, it doesn't make sense for one point to belong to increasing and decreasing. That's why I use parentheses for it. Okay, now if you go to calculus, that's exactly what we do. But in this case, since the book allows that, in case you plug in the other, you won't be penalized on the exams. I'll recommend use what, I mean, parentheses instead of what, brackets. Now, if you write this way, it's also be what, to be the my MATLAB will accept it, okay, comma, and then from what, 3 to what, to 4. All right, now let's talk about decreasing. Okay, now where is it decreasing? Where is the function going what, downhill? All right, if I change my color, if I change the color, you can see that it is going downhill from this part all the way to this point. So when from this interval, okay, from this to that, between 0 and then 3, the function, the y value is decreasing. Going what? Always we are moving from left to right. Okay, so then this is going to be, or to be the answer, okay, it's going to be from what, 0 to what, to positive what, positive 3. Or you can write it as what, using brackets, 0 to what, 0 to 3. Okay, then where is it flat? That is constant. Where is the function constant? Yeah, we can see it from here. Okay, if I pick if we pick this one, it's going to be here. See the green part, it is constant there. So what are the x values? It will be from what, -4 to what, -4, -2. Or you can, if you want to use the brackets, it will be what, from -4 to -4, -2. Okay, so this is to show you, but for the rest of the class, I'm going to use parentheses to write these down, so that will be consistent. Okay, all right. Okay, so then we talk about average rate of change. Please, they are bringing this at this point to prepare you for calculus 1. Okay, So average rate of change and then the slope of a secant line and everything, when you get there, it won't be something new. But average rate of change is basically changing y over what? Changing what? Changing x over an interval of the value. So if you have A and B, okay, that A is not equal to B. If A is equal to B, then we are talking about the same point. So the average rate of change of f from A to B is given by what? This formula, which is the function value at the B minus the function value at what? At A, divided by the difference between what? A and B. Okay, so this is the formula. We're going to apply it to solve some problems here. All right, so it says that find the average rate of change of the function for the function s squared plus what? Plus 1 from 1 to 2 and from 0 to what? 0 to 2 on this graph. All right, so what is the average rate of change? It's basically the slope of the what? Of the line joining the 2 points. Slope of the line joining the 2 points. Okay, let me write this here. This is basically slope of what? The line, okay, joining the points at x is equal to A, s equal to B. Basically, that's what it is. Now, if you go to this example, part A, okay, bit from 1 to 2, when x is 1, okay, which is this point here, and then x is equal to 2 is that point, with the coordinates 2, 5, and 1, 2, 2, 5, what, respectively. What's the average rate of change? Okay, the average rate of change, which is what, denoted by change in y over change in x, we call it delta y over delta x, is what? It is f of what? It's given by f of b minus f of a divided by what? B minus a. Now at this point, your b is what? 2. Your a is what? Is 1. And then the function value is given like that. So we have, this is going to be f of what? 2 minus f of 1 divided by what? 2 minus 1. So let's find what is f of 1. F of 1 will be 1 squared plus 1, which is what? Which is 2. What is f of 2? Will be what? 2 squared plus 1, which is what? Which is 5. Okay, now remember my f of x is what? X squared plus 1. Okay, so then if you complete this change of rate of change, it's going to be what? 5 minus what? 2 divided by 2 minus 1. So this gives me 3 over 1. And that is what? That is what? That is 3. So therefore, the average rate of change is equal to what? Is equal to 3. Okay, we will repeat it for the second part using the same function and the same graph. Okay, the average rate of change between what? The x is equal to what? 0 and s equal to 2 is the line. Basically, like I said, it is what? The slope of the line joining the points at x equal to 0 and s equal to 2. And so we have change in y, that's the average rate of change, divided by change in x is equal to f of 2 minus f of 0 divided by 2 minus 0. Okay, so what is f of 2? When we plug in, I think we got 5. F of 0 will be equal to 1 divided by what? 2 minus 0. And this is what? 4 over 2, which is equal to what? Is equal to 2. Now, let's evaluate this square. What is f of 0? Okay, that's 0 plus 1. That's why I got 1. And f of 2, we got what? 2 squared plus 1. That is what? That is 5. That's why I have these values, 5 and what? And 1. Okay, so that gives us what? The average rate of change. And then the last thing is we'll find the slope of the secant line. Okay, like I said, if you have the points with the coordinates a and f of a, and then b and at what? The function value at b, what is the slope of the secant line? It's basically the slope of the line joining what? The 2 points. Okay, a, these 2 points. If you call this is 1 point and that's what? That's the second one. Okay, so we're going to write it and write it in the point slope form. Just a reminder, What's the slope? Remember, slope of a line denoted by what? M. That's y2 minus y1 over x2 minus s1, which is same as what? The kind of the average rate of change, right? Now, the slope, the point slope form of equation of a line is y minus y1. That is when you have the point x1, y1 line on the graph. Okay, so let's give an example. We are given the function g of x is equal to x squared minus 3x plus what? Plus 2. It says find the average rate of change, okay, from x is equal to 1 to x is equal to what? 3. Now, what is the average rate of change? All right, this is what? The average rate of change is g of 3 minus g of 1 divided by, sorry, let me erase that. Doesn't look nice here for me. Okay, I'll pick a point. Let me change the color. This is equal to what? G of what? 3 minus g of 1 divided by the what? 3 minus 1. Okay, but what is g of 3? G of 3 is going to be 3 squared plus 3 times 3 plus 2. This is what? 9 minus 9 plus 2, which is what? Which is 2. What is g of 1? G of 1 is what? 1 squared minus 3 times 1 plus what? Plus 2. This is 1 plus 2 is 3 minus 3 is what? It is 0. So the average rate of change for this is what? It's going to be 2 minus 0 divided by what? 3 minus 1, which will give us what? 2 over 2, which is what? Which is 1. Okay, so if you have to find the equation of the what? The line joining these 2 points, we can write it in the next slide. All right, it says that find an equation of the secant line containing these points. Okay, now your g of x is what? X squared minus 3x plus what? Plus 2. We just found what is g of what? G of 3. We got 2. What is g of what? 1. We got 0. Okay, so these points, 1 comma g of 1 is basically the same as what? 1, 1, 0. And then 3 and g of 3 is the same as the points what? 3 and this is what? This is 2. Okay, so if you pick any of the point, let's use the point 3 what? 3, 2. Okay, and then the slope of this was secant line. Okay, m is actually what we just got, which is g of what? 3 minus g of 1 over what? 3 minus 1. We got what? We got 1. Okay, so the point slope form of the equation of a line is what? Y minus y1 equal to m times x minus x1. So you get y. What is y1? Y1 is 2, and then m is 1, and then x minus what? 3. Okay, so when we simplify this, we have what? Y minus 2 equal to x minus 3. And then you have y is equal to x minus 3 plus 2. When you add 2 to both sides, so you have x minus 1 and then y. This will be the equation of what? Of the line in what? What form? This is the slope intercept what? Intercept form. Okay, so this is finding the slope of a secant line, the average rate of change, increasing and decreasing, and that ends what? This video. The second part will follow soon. Thank you and see you next time. Bye-bye.